Hello everybody. So today I'm going to talk about 14-3, which is kind of a broad overview of the various different trig ratios. So first of all, we've already looked at sine, cosine, and tangent. Okay, and we talked about those as a ratio of sides previously, both in this class. And if you think about geometry, you looked at these before, right? So sine is what? It's always going to be, well, the y value, and we're calling it r here, okay? R is just basically the hypotenuse. So if we're looking at an angle right here, okay? We have some sort of angle, right? We have some sort of x value associated with that. We have some sort of y value associated with that. And notice that forms a right triangle, okay? Now previously, all the circles we have been looking at is unit circles. And so we're relaxing that assumption now, okay? So when we're talking about the size of these triangles, before kind of the maximum length right here, before that was always going to be 1, right? Because the radius of the unit circle is always 1. Now we're just going to assume, well, that can be anything, really. But it doesn't really make it much more complicated. Basically, you have 3 sides to your triangle. You have a point for x and y. You have one side that will be x, one side that will be y, and then you have r over here, which is essentially the hypotenuse of the triangle, okay? So remember again, if you have an angle of interest, you have the side opposite it, you have a side adjacent to it, and of course you always have the hypotenuse, okay? So there's 2 different ways you can look at these trig ratios. So for example, going back to sine again, well, what is sine? It's going to be y over r, which is the opposite to the angle over the hypotenuse. Cosine is going to be x. Here's x right there, which also is the adjacent side, again over the hypotenuse, which is the r. Then we have tangent. Okay, tangent is going to be y over x, which is again the opposite side over the adjacent side. Okay, and then you have what's known as the 3 reciprocal trig functions. These guys are just, again, the exact reciprocals of the previous 3 we talked about. So, for example, cosecant is the reciprocal of sine. All right, so instead of y over r, it's r over y, or hypotenuse over the opposite. Secant, reciprocal of cosine. Again, it's just flipped around. R over x, or hypotenuse over adjacent. Cotangent is reciprocal of tangent. So instead of y over x, you have x over y, which is the adjacent side over the opposite side. Okay, so let's find some trig ratios. So let's take a look at number 7 from the homework. So in number 7, they give you a point. The point they give you is -4, 3. And I graphed it right down below here. Okay, so remember your axes. So you have an x-axis right here. You got a y-axis right there. What does that mean? Well, if we're thinking about these values, that -4 obviously is going to be at x, right? That 3 is obviously going to be a y, but we need to find, well, whatever the hypotenuse is right there, okay? It is pretty easy, right? I'm sure you guys can do this. Pythagorean theorem type of problem. You just do 3 squared plus -4 squared is equal to whatever that r squared is, and I think you can work it out. It's going to be 5. Okay, so that's equal to 5. Okay, and really, all you got to do is plug it in right now to get all these trig formulas. So let's look at these 6 different trig functions right here. So what do we got going on? So sine, y over r, opposite over hypotenuse. What's that going to be? Y is 3, Y is 3, R is 5. 3 over 5. Okay, cosine. Well, now, what's x? It's negative 4. What's the hypotenuse? It's 5. So it's going to be negative. And these can be negative. That's fine. Okay, negative 4 over 5. Tangent. Tangent is y over x, or opposite over adjacent. So let me see. So it's going to be negative, y over x. It's going to be 3 over negative 4, or negative 3/4. Okay, the other three are piece of cake. Now that you've got the original three, the reciprocal functions are the reciprocals. And so cosecant is going to be 5 over 3. Secant is going to be negative 5 over 4. Tangent will be negative 4 over 3. Okay, not too bad. Let me know if you have any questions on that. But let's take a look at some application problems now. Now, you've probably done these in geometry. But it might have been a while since you've actually had to do these, so I think it's good to review. So we're going to look at 15 and 19 here, okay? So number 15, that you need to solve for x, okay? So let's see what they give you. They give you an angle. They give you a side. And you're solving for what looks like to be the hypotenuse. We know it's the hypotenuse since it's opposite the right angle. So we want to use one of our trig functions. Which trig function is the best one to use? Typically, don't want to try to use, I recommend you don't try to use the reciprocal ones. Just use the three standard ones, sine, cosine, tangent. Which one is the best one to use here? Well, if I'm talking about the 55 degrees, okay, so I know I'm going to have a hypotenuse, so that means tangent is out. Well, what is the 24? Is that adjacent or opposite the 55 degree angle? Well, this side is opposite, right? So this side would then be adjacent since it's next to the angle, but not the hypotenuse. So which trig function is that? Well, if we take a look back over here, oh yeah, that's going to be cosine, right? Adjacent over hypotenuse. Great. All right, so let's plug in what we know. Grab this guy. Let's see, so it's cosine of 55 degrees is equal to, let's see, it's adjacent over hypotenuse. So that's going to be 24 over x. Okay. Oh, all right. So it looks like I just have to solve for x. So what am I going to do? Well, I'm just going to manipulate the equation like this. And now you can just do this on your calculator. Remember, now notice how this is in degrees. Remember the modes, right? This one's, you're given degrees. Your calculator must be in degree mode. Very important. If your calculator is not in the right mode, you're not going to get the right answers, okay? Make sure it's always in the right mode. It's in degrees for this problem, so your calculator must be in degree mode. Remember the calculator, the mode key is right towards the top, right next to the blue second key. And then you scroll down to like the fourth line right there, and you'll see radians degrees, okay? Again, let me know if you can't find that. But once you got that set up right, this is a piece of cake. You just do 24 divided by the cosine of 55 degrees on your calculator, and that is about a 41.83. If you get something different from that, calculator is in the wrong mode. Okay. Now 19. Okay, 19 asks you to find all the missing values. Okay, so that means we got to find. They give you B and C. And you have to find the missing angles and sides. Okay, so what that means is, well, you got to find the side right here, side A, and you got to find angle A and angle B too. Looks like we know C. We know C is the right angle. So there's three things we need to find here. Let's do the side first. That's pretty easy because it's just, again, Pythagorean theorem. So what do we got going on here? It's going to be a squared. We know 10 is the hypotenuse, so set it up and just solve it. I think you guys can do this. Okay, subtract the 25, square root it. So you get 8.66. 8.66. Okay. Now to get the angles, you got to remember how to do the inverse of trig functions. I'll write that a bit neater. You got to remember how to do the inverse of trig functions on your calculator. Okay, so let's say we want to find angle A. Okay, well, again, what trig function? If I'm looking at angle A right there, right? Well, what sides am I working with? By the way, I recommend you use the sides that are given to you, just in case you made a mistake in finding A. You don't propagate that mistake later on. So I'm going to stick to using the 5 and the 10. What are those two sides, though? Well, 10 is clearly the hypotenuse. And if I'm talking about angle A, well, we don't want this side. That's, well, we could use it, but that's the one we calculated. So I'm not going to use this one. I'm going to use this 5. So relative to angle A, 5 is adjacent to it. Right? It's right next to it. So we're talking about an adjacent side and the hypotenuse. Well, again, that's cosine, right? So let me write that out. So the cosine of the measurement of angle A, which is what I'm trying to find, is what, 5 over 10, or 0.5. All right. So I got to solve for the measurement of angle A, which means I have to do an inverse trig function. Okay, so to both sides, I'm going to write it like this. Cosine to negative 1, it's like it means inverse. Oops, let me hold on. And so I'm doing the inverse cosine of both sides, so on the left and the right. Oops, I forgot to write it again. So also the inverse cosine of this side. Okay. Why do we do this? Well, we do this because inverse cosine and cosine cancel each other out. So what happens is that, well, because I'm doing that, both of these go away. And what I'm left with on the left is what we want, the measurement of angle A. And now to do the inverse cosine of 0.5, again, that's on your calculators. If you hit the blue second key in the upper left and the cosine, that would do inverse cosine. And what you're doing is you're finding the angle that is gives you a cosine value of 0.5. Okay? And again, make sure you're in degree mode. And if you put this in your calculator and you do the inverse cosine of 0.5, you should get a nice round, 60 degrees. Okay? And now that just leaves us with the measurement angle B. We're almost done. This one's super easy because we know, though, there is only 180 degrees in triangle. We know one of them already is a 90-degree angle, so that means the other angle has to be 90 minus 60 degrees, or 30 degrees. Okay? And that's it. You're done. We found the two missing angles, and we found the one missing side. So we're all set. Okay? So remember, make sure you're in degree mode. Okay? Make sure you're in degree mode whenever you're solving problems with degrees. So you have to kind of pay attention. And also remember that to solve a problem like this one right here, right? If you want to get rid of the cosine, well, how you get rid of the cosine to find the measurement of the angle is an inverse cosine, or an inverse sine, or an inverse tangent, depending on, which particular trig function you're working with. Okay, so that's it for today. So thank you guys, and please let me know if you have any questions.